Good afternoon. My name is Sang, and today I'll be presenting on my project on Sunnyside Dispensary Queuing System. Located in Champaign, Sunnyside Dispensary offers both medical and recreational cannabis products to the customers. The store operates on a single queue multiple server system. When people shop at the store, they first have to wait in a line that is both inside and outside of the building. Once the wait is over, the customers get served by one server with the estimated service rate. After the customers are served, they exit the system without any delay. The purpose of this project is to find the best number of servers that can minimize the profit loss. The profit loss will be calculated from the number of customers that barked and the labor cost. The simulation will be run with different numbers of servers, and it'll focus on a busy period, which will be set from 1 p.m. to 3 p.m. on the weekend. There are a number of assumptions made in order to simplify the system. First, all servers are assumed to have the same experiences and skill sets, and therefore the same service rate. Second, the bark tolerance for customer is a random number of triangular distribution with min equal to 8, mod equal to 12, and max equal to 15. Third, no shift changes or breaks occur during the simulation time. Fourth, the system starts empty and idle. And lastly, when a customer barks, the store loses $20 and the salary of the server are set as $13 per hour. There are two main entities of the model, which are the server and the customer. Server has attributes such as experiences and skills, busy or idle, service rate, and work hours. Customer has attributes such as in queue or being served, arrival rate, type of customers, and the bark tolerance. The simulation was built using Simio, and the simulation captures variables such as number of customers who barked, number of customers arrived, and the number of customers served. The number of customers that barked is the essential output measure that will be used to calculate the profit loss. The number of customers served and arrived will later be used to reduce the variance in the output measure. To validate the two essential model parameters into the arrival rate and the service rate, I collected data points for arrival times and service times and conducted an Anderson-Darling goodness of fit test. The test displays Anderson-Darling correlation values for all distributions, and the distributions with the highest correlation was chosen to represent the distribution for the two variables. For the inter-arrival rate, exponential distribution with the mean equal to 3.76 was chosen, and for service rate, exponential distribution with mean equal to 4.98 was chosen. On the tables, the results for the goodness of the fit test are shown. As shown, for both variables, exponential distribution had the highest Anderson-Darling correlation, and therefore, they were the distribution chosen for the variables. There are 5 main events in the simulation. First is the initialization of the simulation. At the event, the simulation starts empty and idle. Second is the arrival event. During this event, the number of customers in the queue is increased by 1. Third, the begin service event. During this event, the number of customers in the queue is decreased by 1. Also, the status of the server who started serving is changed from idle to busy. Fourth, end of service event. During this event, the status of the server who finished serving changes from busy to idle. And lastly, customer bark event. During this event, the number of customers in the queue is decreased by 1. Also, the number of customer barked is increased by 1. This event occurs when the queue size is higher than the customer's bark tolerance. Here are the list of analyses performed for the output measures. First is the analysis on the input dependencies. Second, declaration and calculations of the performance measure. Third, variance reduction. And finally, the conclusion. Before getting into analysis on the output variables, it's important to analyze the dependencies in the input variables as they can affect the output variables. In this simulation, the two most important input variables are the inter-arrival time and the service time. Using the equation shown, the two variables were proven to be dependent. Then, a Pearson correlation value was calculated to indicate the exact correlation value between the two variables. The result shows a small and a positive correlation value equal to 0.196, which indicates a small and a positive dependency in the input variables. Because the correlation value is low, the output measures are less likely to be affected by the dependency. After the analysis on the dependencies of the input variables, the type of performance of the model was studied. Because the simulation model has a natural event that specifies the length of each simulation run, which is 2 hours, the model can be considered as a transient or a terminating simulation. With the declaration of the model as a transient simulation, the performance measure of interest was determined, which is the expected number of customers who bark during the busy period. To calculate the performance measure, simulation was performed with 30 replications in order to ensure that the central limit theorem holds. The table summarizes the output measures calculated, which are the expected number of customers that barked, the variance, and the confidence interval. For single server system, the expected number was 2.467, whereas for two server system, the expected number was 0. Because the expected number for two server system was 0, systems with more than 2 servers were discarded, as that would only increase the total labor cost. Before drawing any conclusions based on the output measures calculated, variance reduction methods were considered. Because the variance was 0 for the 2 server system, the variance reduction method will only be considered for the single server system. The method chosen was reduction using control variates. 2 control variates chosen were the number of customers arrived and the number of customers served. Using the number of customers served as a control variate, the variance was reduced from 13.154 to 0.02, which is a tremendous improvement. Because using number of the customers served as a control variate resulted in a higher variance reduction, we will use this output measure to draw conclusions. Finally, with the variance reduced output measures, conclusions were drawn on the number of servers that can minimize the profit loss. For single server system, the total cost or profit loss was $62.34, whereas for 2 server system, the total cost was $26. Therefore, we can conclude that during the busy time, hiring 2 servers is recommended in order to minimize the store profit loss. However, it's important to keep in mind that because the data collected for the project was during the COVID-19 situation, the simulation result might not be applicable to the normal times. Thank you for listening, and I hope you all stay safe.